So imagine for a second that our solar system isn't, just some messy, random accident of colliding space rocks. Imagine it's actually a giant, perfectly tuned cosmic instrument where planets can only exist in very specific grooves.
Right, like a carefully structured system.
Exactly. Welcome to today's deep dive. You, our listener, sent us this really fascinating stack of notes on Gautam Pal's K7 theory, which is also known as the universal rule of seven. And our mission today is just to unpack this radical framework. It basically proposes that the arrangement of our solar system is actually a highly synchronized, macro-scale harmonic resonator.
Yeah, it completely reframes how we look at the space around us. I mean, for centuries, we've relied on these smooth, continuous gravitational dynamics to explain planetary orbits, right?
Sure, like a smooth slope where a planet could just settle wherever.
Exactly. But Pal, well, his background is actually in high-energy particle physics, and he suggests that orbital stability is quantized. So it's not a smooth slope. It's more like a set of rigid stairs.
Okay, so how do we find the bottom step of these stairs?
Well, to find that foundational tuning, Pal looks at Mercury. Mercury's mean distance from the sun is 0.387 astronomical units. So that's roughly a third of the distance between the Earth and the sun.
Right.
And the K7 theory divides that distance by 7.
Why 7, though? Is there a specific reason?
Yeah, so in wave dynamics, a base 7 harmonic structure naturally emerges as the most stable configuration for a standing wave. And that's essentially what the early solar system was. So dividing Mercury's orbit by 7 gives us this foundational K unit of about 0.0553 AU.
Wait, so every planet's distance is just that exact K unit multiplied by a specific whole number, like a harmonic point.
That's exactly it.
I mean, it's exactly like the frets on a guitar. Like, you press your finger on a fret, you get a clear ringing note. But if you press the string in the empty space between the frets, you just get a dead thud.
That's a great way to put it.
Yeah.
In this model, a planet can only form on the fret, right? A stable resonance node. It just simply cannot exist in the empty, unstable space between them.
Wow.
And the math backing up that standing wave model is just staggering. If you apply that simple formula, a whole number multiplied by the K unit, it predicts the observed distances of the outer bodies, like Jupiter, Saturn, Uranus, Neptune, and even Pluto, with greater than 99.9% accuracy.
That's wild, but I'm looking at this perfect mathematical grid in the notes you sent over, and I'm a bit hung up on the massive empty gap between Mars and Jupiter. I mean, if the frets are perfectly spaced, why is there a huge dead zone right there in the middle?
Well, the theory defines those dead zones as great jumps. And they are actually mathematically required by the acoustics of the system.
Oh, really?
Yeah, that gap isn't just a place where a planet failed to form. It's a region of destructive resonance interference. Jupiter is so massive that when it coalesced at its specific node, it sent this overpowering gravitational wave back through the accretion disk.
So it essentially cleared the area.
It shattered the intermediate nodes. It made it physically impossible for matter to stabilize there. The asteroid belt is literally just the lasting physical debris of that destructive wave.
Wait, but if Jupiter's wave was so destructive that it shattered those intermediate nodes, how did Mars manage to survive right next door? Because looking at the data here, Mars's placement seems a little off. It's sitting at only 98.4% accuracy to its predicted node.
Well, Mars barely survived, honestly. It's sitting right on the absolute edge of that turbulent asteroid belt, kind of trapped under Jupiter's immense gravitational shadow.
Oh, so it's constantly getting pulled.
Exactly. Over billions of years of geological time, Jupiter has continuously tugged Mars just slightly off its theoretically perfect node. The underlying harmonic grid itself is flawless, but the physical planet has just been dragged out of tune by its giant neighbor.
That makes sense. And this is where the notes you shared really blew my mind, because the implications go way beyond just planets, right? The math governing these planetary frets apparently applies to entirely different scientific disciplines.
Yeah, it really does. Because Pal is a particle physicist, he actually looks for these macro-scale K7 harmonic patterns in microscale realities, and he found them.
Like where?
Well, these exact same spatial distribution laws govern the freeze-out of quark-gluon plasma. That's the ultra-hot fundamental soup of particles that existed just fractions of a second after the Big Bang.
Oh, wow.
Yeah, as that plasma cooled and stabilized into matter, it locked into the exact same base 7 harmonic intervals. And astoundingly, this harmonic gradient math also models biological growth.
Wait, biology too?
Yes, specifically retinal nerve fibers in the human eye. It dictates the precise spatial distances at which those cells branch out so they can optimize light capture without interfering with each other.
So the universe isn't just running some generic software. It's actually using the physical geometry of sound and resonance as a universal building code.
That's the idea.
I mean, the math that spaces out planets to avoid gravitational collapse is the exact same math spacing out nerve cells to avoid biological crowding. It scales perfectly from the cosmos all the way down to the eyeball.
It really is incredible, and the ultimate test of this universal building code is its predictive power. The math dictates a full 14-planet sequence for our system.
Wait, 14. We only know of, what, 8 or 9, depending on who you ask?
Right, which means there are exactly 5 massive, undiscovered celestial bodies hiding in deep space beyond 1,000 K units. And because we have this harmonic blueprint, astronomers don't just have to guess where to point their telescopes anymore.
They don't know exactly where to look?
Exactly. They can use 1K incremental scanning to target the exact spatial coordinates where these bodies must mathematically exist.
We literally just have to check the remaining frets on the guitar to see what notes are playing in the dark. That is so cool. And it leaves a really massive thought for you, our listener, to ponder today. If the macroscopic arrangement of planets operates on these discrete, quantized steps, just like subatomic particles,